Welcome back to Learning with me, Ms. Killen here at MPB. We are in our new unit, Unit 3, our inequalities. So let's jump on in and see what we've got. We are reviewing our inequality meaning. I can solve inequalities by graphing and applying properties for solutions. We are looking at A-REI.3 and A-CED1. So let's go ahead and see what we've got. All right, so let's do some review on these inequalities. If x is greater than -3, then it would look like this on the number line. Notice how I have an open circle, meaning it cannot equal the 3. And then I have it where my x's are going to the larger or to the right. That's what this inequality would look like. Now, what if we had this? X is less than or equal to 3. How would we write that? Exactly. I have a closed circle. So I'm going to put it up here on the board. You put it on your paper and let's see what we got. So I'm going to put a 0 and I'm going to put a 3. I'm going to have a closed circle. And then I'm going to show that all of my x's are smaller than 3. All right, noticing that I have a closed circle, meaning it can be a part of my solution. Open circles cannot be a part. Closed circles means they can be a part of the solution. That was a good job. All right, so let's look. It says these are our inequalities. Now, on a piece of paper or on your inequalities notes page, let's go ahead and make some notations about these. I'm going to put them up here and make sure that you're writing them down because we are going to use these meanings the whole unit. So here we go. So my first inequality I have is my less than symbol. So I have less than. My next one is less than or equal to. Noticing I have a line underneath. My next one is my greater than symbol. And then I have greater than or equal to. Now you're probably asking, Ms. Killen, what about the big green dots? Well, noticing I have an open circle here, and what we've already talked about with our open circle, it cannot be a part of the solution. Notice the inequalities that are above the open circle. They do not have a line. But now look at my closed circles. I have less than or equal to, greater than or equal to, where my number can be a part of my solution. So when I have the line underneath my inequality symbol, I have a closed circle, meaning I can incorporate that number with my solution. Good job. All right, so now I want us to look at some more words, some more phrases that can mean these different inequality symbols. I'm going to put them on the board. You need to either put them on that inequalities notes page or a page that you're keeping these words and phrases because they're very important. So here we go. So the first one I have is my less than or equal to. So I'm just going to put that. I'm going to put less than. Let me make sure we are writing so I can read it. So I have less than or equal to. It could also be, this symbol is at most. It could also mean no more than. No more than. And notice it is a closed circle. The next one we have is our less than symbol. So it's just plain less than. It's also smaller than. And we've also seen the wording below. All right, my next one is my greater than. Also more than. And then larger than. Making sure that everything is bigger than what's behind it. Noticing that I have an open circle for my greater than, open circle for my less than, and then our last one is greater than or equal to. So I have greater than or equal to. Also, no smaller than. That's a new one that we've probably not seen as much. And then our last one is at least. Noticing that I have an open circle. Now, some of these words and some of these phrases may be common, but some of them are kind of new to us. So the more that we get into this Algebra 1 course, we're going to see a whole lot more of these uncommon ones so we can get used to seeing and how we work them. Good job. Let's see what we've got. All right. How would you write these phrases using inequality symbols? So I'm going to do them on the board and you follow along with me on your paper. Number 1 says 5 is greater than an unknown. So obviously I have 5. So 5 and my unknown, I'm going to use x. So it has greater than. So that means it's bigger. Well, Ms. Killen, why didn't you put the line underneath? Because it doesn't say equal to. Now, some of us have a hard time which part of my inequality goes with which part to the number or to the smaller or whatever. So let's go ahead and write that down. Here is my inequality symbol. Now, when we're looking at an inequality symbol, the smaller part of the symbol goes to the smaller number. The larger part of the inequality symbol goes to the larger number. Now, sometimes we've had people tell us, well, just look and see the way it points. That's not always going to be the case because depending on how you write it, depends on which way the point may go. So the point may be going left, but then you have to graph right. So instead of looking at points, we need to read the meanings of the symbols. All right, let's look at number 2. 3 is no less than an unknown. So I have, let's just write the unknown first in 3. But no less than. How would I write that? 3 is no less than an unknown, meaning my unknown is going to be bigger than my 3. So here's another instance where we have to read the meaning of the inequality and not just a point. All right, let's look at number 3. An unknown is at most 17. So I'm going to write my unknown, and I'm going to write 17. So an unknown is at most, I'm going to have that less than or equal to symbol. It is very important, majorly important that we are reading the meanings of our inequality symbols and not just looking at points. Okay, so let's do number 4. 13 is greater than or equal to, I'm going to annotate that problem, and unknown. So I have 13 and I have an unknown. Greater than or equal to, so there we go. 12 is not equal to t. Now, here's something that a lot of us have not used as much, but we will be using further on in the course. So I have 12 and I have t. Is not equal to, meaning there's no way they can be the same thing. So the way I show that is an equal sign with a line between it. There's no way that 12 can be t. Those were good jobs. All right, so let's look at the next one. Inequalities show how numbers, variables, or both compared to each other. True values can be said of inequalities, just like equations can be true or false, so can inequalities. So let's look and see if these are true or false. So let's look at this problem number 3. I have 13,289.01 is greater than 13,289.001. So how can we compare these? Now, they're both 13,289, so now I'm going to have to really focus on my decimal numbers. So let's look at these decimal numbers. I have my tenths and my hundredths. I have my tenths, my hundredths, and my thousandths. So is this true? Absolutely. That is true. So let's look at the next one. 45 over 4 is greater than or equal to 11.25. Ms. Gillen, we're comparing two different things, but are we? I have a fraction and I have a decimal. Is there a way that maybe I could take that fraction and make it into a decimal? Exactly right. Let's get our calculator. So I'm going to put 14 over 4 and make it into a decimal. Now, 45 over 4 and make it into a decimal. Now, there's two ways. I can put the fraction in my calculator and then go to my math and make it a decimal, or I can put 45 divided by 4. I'm going to do it both ways and make sure that I get the same number. You do it as well on your calculator while I do it up here, and let's compare. So the first thing I'm going to do is I'm going to put the fraction. I'm going to do alpha y equals and take my number 1, put 45 on top, put 4 on the bottom. Scrolling out of that fraction, I'm going to go to math and hit number 2 and enter. I get 11.25. But let's double check. Always measure twice before you cut first, so to speak. So we're going to make sure that the measurement is right before I make it a true or false statement. So now I'm going to take 45 division 4, and I get 11.25. So this is true. But you're sitting there going, Miss Killen, but it's not greater than. It's not greater than, but it's what? It's equal to. So that was a good catch. We want to make sure that we're reading the meaning of these inequalities, not just points. Okay, so let's look at this. -8 is greater than -4. Oh, yeah, that's true. But is it? Now, if we were talking about +8 and +4, that's absolutely true, but we're not. We're talking about negative numbers. Well, Ms. Killen, I don't really remember a lot about those negative numbers. Let's draw a number line up here and see. So if I had 0 and I go backwards, -1, -2, -3, -4, -5, -6, -7, -8. So when we learned about negative numbers, we learned the closer to 0 with negatives, the bigger the number. When we talk about positive numbers, the closer to 0 with positive numbers, the smaller the number. So since we're looking at negatives, the closer to 0, the bigger the number. So this is going to be little, and this one's going to be bigger. So I can say -8 is not greater, so this statement is going to be false. Now let's look at -3/4 less than or equal to -5/6. Let's put that in our calculator and see what we've got. So we know multiple ways to put this in our calculator. I'm going to put the fraction in and turn it to a decimal, just so I can see how many decimal points. So I'm going to do alpha y equals and put -3/4. I'm going to go to math and hit number 2, and I get this decimal number. All right, now let's put -5/6 in there. So I'm going to do it again with my fraction, -5/6. Go to math and hit number 2, and I get this decimal number. So here's my question. Is this a true statement? Well, we know they're not equal to. Absolutely not. But is -0.75 smaller than -0.83333? It's not. So this one is also false. This one is smaller. This one is bigger. The more that we work with these negative numbers, we'll be able to see, oh, okay, the closer I get to 0, the bigger the number. The further away I get from 0, the smaller the number. This one is closer to -1 than this one is. Therefore, my -3/4 is closer to 0. All right, that was a good job, guys. Let's look at it next. Our inequalities represent boundaries or limits. Inequalities do not represent exact numbers or exact amounts. Now, when we're talking about inequalities, we have a whole bunch that can be part of our solution. Okay, so if x is less than 3, does that mean it's 0? Does that mean it's -127? Does that mean it's 2? So there's multiple numbers that can be that possible solution. So we have boundaries. It can't be 3, but it can be lots of things behind it. So we have to look at these boundaries or these limitations with these inequalities. All right, so time for you to master. We've done all of this practice. It's time for you to master. Inequalities tell us information we use to know how to read what the possible solutions can be and where they're located on a number line. They establish relationships between quantities, indicating that one expression is not equal to, but rather less than, greater than, or possibly equal to another. So it's all about the relationships. Everything in math is about the relationship. It's kind of like us as people. Everything's a relationship. So when we look at these inequalities, we've got to compare the relationship between one number or variable to another number or variable. So let's look. Write the inequalities for each phrase. Make sure your variables make sense for the scenario. So you and your table partner, go ahead and work 1 through 5. When you get done, come back to me and let's see what we got. Okay, are y'all ready? Here we go. Number 1, the number of apples is more than 10. Since we're talking about apples, I'm going to use A, and it says apples is more than 10. So I've got 10. So I'm going to show that A is the larger of the two in this relationship. Let's look at number 2. The cost of the tickets is less than $20. So I've got my tickets, I've got my $20, and I've got that they are less than. So my T would be the smaller number in the relationship. Let's look at number 3. The area of the garden is smaller than 100 square meters. So I've got my garden, I've got 100 squared meters, and it says that the garden is smaller than. So I'm going to use that less than symbol. All right, number 4, the amount of money raised was at least $10,000. So we've got money. I've got $10,000. We'd all like to have that. So it says at least. So that means it can be bigger or it can be equal. So my M, or my variable, is going to be the bigger one in the relationship. Let's look at the last one. The number of students enrolled exceeds 100. So I've got students, and I've got 100, and the enrollment is going to be bigger because it exceeds 100. That was a good job. Compare my work to your work. See if we used the same inequality symbols. Well, Ms. Killen, I didn't necessarily use A for apples. Maybe I used X for apples. That's fine, as long as it makes sense with the scenario. We want to make sure that we have usable variables. Good job. All right, so we don't want to forget what each inequality symbol means. We have less than or equal to, we have greater than or equal to, and we want to remember how our phrases can mean different things for different inequalities. Inequalities show boundaries. I am so glad that you came to work with me here at MPB today. I am excited to get through this unit of inequalities with you. I am Ms. Killen. Have a great day.